What is vertical takeoff, vertical landing for reusable rockets? Imagine a rocket that can launch straight up into space and then come back down to land gently on the ground, ready for its next mission. That's what vertical takeoff and vertical landing technology is all about. It's a way for rockets to launch and then return to Earth without needing a giant crash landing or being discarded after each use. This method is especially important for reusable rockets because it helps save money and reduces waste. Instead of building a new rocket for every trip, companies can refurbish and reuse the same one multiple times. The process starts with vertical takeoff, where the rocket's engines fire straight up from the launch pad. The engines push the rocket high into the sky, gaining speed and altitude. Once the rocket reaches its desired height or orbit, it releases its payload, like satellites or supplies. After completing its mission, the rocket's first stage, which is the bottom part that provides most of the thrust, turns around for its return trip. Using its engines, it slows down and begins to descend back to Earth. Landing vertically requires very precise control. The rocket's engines are throttled, meaning their power can be adjusted to slow or speed up the descent. Thrust vectoring is used to steer the rocket during its fall, helping it stay on course. Navigation systems, which include sensors and GPS, guide the rocket back to a designated landing site. Many rockets also have landing legs, which are sturdy supports that extend just before touchdown, and grid fins that help steer during descent. Popular examples of this technology include SpaceX's Falcon 9 and Falcon Heavy rockets. These rockets can launch satellites into space and then land back on Earth, often on a landing pad or a drone ship at sea. Blue Origin's New Shepard also uses vertical landing to return from suborbital flights. SpaceX's Starship is designed to use vertical takeoff and vertical landing for both its booster and spacecraft, aiming for missions to orbit and beyond. The main advantage of VTVL is that it makes space travel more affordable. Reusing rocket stages cuts down on the cost of building new rockets for each mission. It also simplifies recovery because landing vertically is easier than horizontal methods. However, there are challenges too. The added weight of landing systems and extra fuel needed for landing can reduce how much payload the rocket can carry. Still, the benefits of reusability and cost savings make VTVL a key part of modern rocket technology. It's helping to make space more accessible and opening the door for more frequent missions.